All right, so here we're looking at example 5 from page 456. In this case, we don't actually know what alpha and beta are, the angles themselves, and we aren't going to find them out, but we still can find out information about alpha and beta if we are given some information. So in this case, we're given the sign of alpha, we're given the sign of beta, and we're also told which quadrants alpha and beta lie in other words, between which values alpha and beta are as angles. Let's take a look at letter A. So we're told to use this information to find cosine of alpha. So taking a look at alpha, which is the first pair of information we're given, the first thing I want to look at is actually the angles. So the right side, the restriction there. If alpha is in between pi over 2 and pi, and I'm just going to draw out our unit circle here to help us out, then we know that alpha is in quadrant 3. So this is pi over 2. This is pi, and alpha is somewhere in between pi over 2 and pi. So that tells us that alpha is in quadrant 3. This is important because it tells us that cosine, the x value, is going to be negative. So quadrant 3 means that cosine is negative. This is really important to know. So cosine is going to be negative. So we know whatever answer we find for A, we will get a negative answer. Next, we know that sine of alpha is 4 over 5, or 4/5. One way to think about this is to actually use the unit circle. I'm going to go ahead and draw. We don't know exactly where this point is. That's fine. Use the unit circle to draw a triangle. We know that sine represents the y value. So sine in this case is 4/5. We know that in the unit circle, the hypotenuse is always 1, radius of 1. And then cosine in this case is going to be this x value. So to find cosine, we can use the Pythagorean theorem. We know that cosine alpha squared plus 4/5 squared equals 1 squared. In other words, cosine of alpha squared is equal to 1 minus 4/5 squared. 4/5 squared gives us 16/25. So cosine of alpha is going to be the square root of, and in this case we end up with 9/25. The square root of 9/25 is going to be 3/5. And this is where the quadrant is important, because when we take a square root, we have to consider both the positive and the negative square root. In this case, we only take the negative value because we know that cosine is negative. Cosine is negative. So cosine of alpha is equal to negative 3/5, and we're finished. So we used both pieces of information to find cosine of alpha. Let's take a look at letter B. Letter B, we're being asked to find cosine of beta. In this case, we are given some information about beta. We know that beta is in between pi and 3 pi over 2. What this tells us is that we're in quadrant, in the previous problem I said quadrant 3, I actually meant quadrant 2. I made a mistake about this. Here we have 1, 2, 3, 4. So quadrant 2 for letter A. For letter B, we end up in quadrant 3. We're in between pi and 3 pi over 2. So somewhere in here. Okay, quadrant 3. This tells us that, similar to problem A, or letter A, cosine is going to be negative again, because our x values are still to the left here of the y-axis. Okay, so we'll end up with a negative answer. Here, we could write out the entire unit circle, draw a triangle. We could also just use the Pythagorean formulas that we know. Okay, so I actually copied this problem down wrong a little bit. It shouldn't be negative root 2 over 5. We're actually given that sine of beta is negative 2 over root 5. The square root is going to be in the denominator. Okay, so to find cosine of beta, let's use our Pythagorean identity that we know. Cosine of beta squared plus sine of beta, negative 2 over root 5 squared is equal to 1 squared. So cosine of beta, we can take the negative square root because we know cosine is going to be negative. 1 minus, and if we were to square this, we end up with 4/5. So cosine of beta is the negative square root of 1/5, which we could write as negative 1 over root 5. And then if we wanted to write it the proper way, making sure we don't have any radicals in the denominator, we can multiply the top and the bottom by root 5. So negative root 5 over 5 is our cosine value. Okay, great. So we found cosine of beta. And we also found cosine of alpha in the first part. Finally, we can use all of these values to answer parts C and D. Let me copy these values down here, and then we'll work on C and D. Okay, so cosines we found in A and B. Sines were given to us here. I rewrote it. They also give us the proper form. Instead of negative 2 over root 5, we have negative 2 root 5 over 5. For letter C, we're being asked to find cosine of alpha plus beta. So here we can use our sum formula that we saw earlier in this section. So cosine of alpha over beta we know is going to be equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And now we just replace these values individually with the values that we found above and then simplify from there. So cosine of alpha is going to be negative 3/5. Cosine of beta is negative root 5 over 5 minus sine of alpha is going to be 4/5. Sine of beta is negative 2 root 5 over 5. Okay, and then we just simplify from there. So the negatives cancel out in the first term. We have 3 root 5 over 25 minus, in this case, the second thing we're multiplying is negative, so we'll end up with the negative value, negative 8 root 5 over 25. So if we combine these, we end up with 3 root 5 plus 8 root 5. So we end up with 11 root 5s over 25. And then I think that's just about all we can do for that one. Yep, 11 root 5 over 25. And then we're finished. So just using our formula and then simplifying from there. Finally, really quickly, let's take a look at D. Same idea. We're just using our sine sum formula. Right, being asked to find sine of alpha plus beta. So again, we can rewrite this as sine of alpha times cosine beta minus cosine alpha times sine of beta. And again, we replace these values individually with the values we found above and then simplify from there. Sine of alpha is 4/5. Cosine of beta is negative root 5 over 5. Cosine of alpha we found is negative 3/5. And then sine of beta is negative 2 root 5 over 5. Okay, so finally, let's go ahead and simplify these. For our first term, we have a negative 4 root 5 over 25. And then we're subtracting, here we get 6 root 5 over 25. So we have negative 4 root 5, and then we're adding 6 root 5. So we just end up with 2 root 5 over 25, and then we're finished like that. Okay, so again, just use our sum formula for sine, plugged in the values that we found in A and B, and then simplified from there. There is a problem similar to this on the homework. So again, we started off by making sure that we identify what quadrants our angles are in. That way we know the signs of sine and cosine values. And then we use the Pythagorean formulas to find the cosine values. And then from there, used all those values with our sum and difference formulas.